Hi. Today we're going through a PAT paper in 2008 looking at the first set of multiple choice questions, questions 13 through 17. Okay, so in question 13, we're told that a boy of mass 20 kilograms sits on one end of a 3-meter seesaw. And we're asked how far from him should a girl sit of mass 30 kilograms to balance the seesaw. Okay, so let's give us a quick sketch. So what this would look like is we'd have our seesaw like this, and we have our pivot here. We have our boy of mass 20 kilograms, so we'll put 20g, that's the force downwards, the weight force. And she, the girl, is going to sit some distance x from the pivot. We know that the boy is 1.5 meters from the pivot because we're told it's a 3-meter long seesaw. So the distance she is from the boy is simply x plus 1.5. So let's find out what x is. What we do is we take moments. So we want it to be balanced. So we want the anti-clockwise moment to be equal to the clockwise moment. So let's consider first of all the anti-clockwise moment, the one that's going to make a rotation in this direction. Well, the pivot point is going to be here. So the moments in this direction are this force, the weight, times its distance from the pivot. So that's 20 times 1.5. And for that to be balanced, we require that to be equal to the clockwise moments. So that is going to be this force, the 30g. So 30g times x. It's force times its perpendicular distance, 30g x, or just 30x. And therefore, we see x is equal to 1.5 meters from the pivot. Sorry, not 1.5, 1 meter from the pivot. And so she must sit 2.5 meters from the boy. So that's D. So question 14 says, when nuclear fission occurs, the mass of the products compared to the mass of the reactants is, and you have to answer the question. Well, what do we know about nuclear fission? Well, nuclear fission releases energy. And what do we know about energy and fission? Well, we know Einstein's famous equation, E equals mc squared. Now what this tells us is that in fact mass and energy are equivalent. And when you're going at very high speeds, this becomes much more prevalent. So you can notice it much more. So if we had two particles and they collide and we get some new particle coming off, well, what's going to happen is energy is going to be released from this process. And we see here energy is in fact equal to mass times speed of light squared. So when you lose energy, you actually lose mass. So as energy is released in the process, this means that the mass afterwards must be less than the mass before, which tells us that the answer is in fact B, the mass decreases. So question 15 says, we have approximately 400 billion galaxies in the universe. One galaxy has 250 billion stars. Our suns have mass 2 to 10 to the 30 kilograms. It's estimated that dark matter outmasses stars by 20 to 1. And we're asked to use this information to estimate the mass of the visible universe. Okay, how are we going to do this? Well, the mass. So there's 400 billion galaxies. Let's do 400 times 10 to the 9. And in each galaxy we have 250 billion stars. Each star, we're told, is roughly the mass of the sun. So that's 2 times 10 to the 30. Okay, so that's the mass of the stars. Well then, what's the mass of the dark matter? Well, we're told that it outmasses the sun by 20 to 1, so it's 20 times the size of the stars, the mass of the stars. So that's exactly the same thing. The mass of the stars, 4 times 10 to the 9, so 250 times 10 to the 9 times 2 times 10 to the 30, but times 20, it's 20 times larger. Well, that's 21 times 400 times 10 to the 9 times 250 times 10 to the 9 times 2 times 10 to the 30. Well, that's 20 times 10 to the 4 times 21 times 10 to the 48. And that's roughly equal to 4.2 times 10 to the 54 kilograms. So the answer is A. Question 16 says, a solar eclipse only occurs when the moon's phase is. Well, for this video, for this answer, I would recommend you look at our video on eclipses, and that'll explain it all to you. But what we require here is that the moon is in fact in between the Earth and the Sun. And this occurs when there is a new moon. So the answer is A. You should know that a new moon is essentially the time at which the moon is in conjunction with the sun. So it's not visible from the Earth. And when it's not visible from the Earth is when it blocks out the sun, so there's no light to see it. And this will be when it's completely in the way of the sun. And as I said, I would recommend watching our video on eclipses to fully understand this. This is required knowledge you have to have for the exam. So in question 17, we're asked what happens when an ideal gas is heated in a container of fixed volume. What do we know about our ideal gases? Well, we know we have one very important equation. PV is nRT. Where P is the pressure, V is the volume, N is the number of moles, R is the gas constant, and T is the temperature. So I'm going to underline what stays constant. Well, R is a constant, so that stays constant. N is the number of moles, or it's a container, it's a closed container, so N's not going to change. And then our volume, V, also is constant because it's a container of fixed volume. So the only things that are going to change is the temperature and the pressure. So we're told the temperature goes up. And clearly, if the right-hand side goes up, the left-hand side must also go up. So we see the pressure must rise. What else? Well, the options are A, the pressure and density both rise. B, the pressure rises and density falls. C, the pressure rises and density stays the same. And D, the pressure stays the same and the density falls. So we need to consider what happens to the density. Well, density is mass over volume. The number of moles doesn't change, and the volume doesn't change. So clearly the density isn't going to change. So that means we must have the pressure rises and the density stays the same. So the answer is C.